Dear participants, my name is Bogdan Molodets and I would like to present to you information system of air quality assessment using data interpolation from ground station. Monitoring ground station is crucial for creating interactive maps that assist in assessing air quality. For today, many studies have been conducted with methods for assessing air quality and the factors that most affect air quality. At this slide, the image shows nitrogen dioxide overall based on Copernicus Sentinel-5P mission data. Also, there is air pollution map of Lviv region taken from 2016, which was created by scientists from Lviv Polytechnic National University. In general, the ecological state of the environment of Lviv region was satisfactory. However, Kamenka-Buzhsky, Sakalsky and Stry district had the highest level of pollution with harmful substances such as methane, nitrogen dioxide and carbon monoxide. It's necessary to develop the information system which solve this problem by predicting air quality, notifying user about danger. System of air quality monitoring is a system which visualizes current air quality state in real time, saves historical information, storage and build pollution forecasts. In this regard, scientists from OLES, Dnipro National University and Dnipro University of Technology developed methodology of creating an information system that grab and analyze data from various sources such as ground station for air quality assessment. Air quality index, imaginary unit of measure which is used by government agencies, private companies to inform citizens about the level of air pollution. The US AQI, which was developed by the Environmental Protection Agency to facilitate understanding, was chosen in the current information system. It's divided into 6 categories. Each category has its own impact on health. All levels of indexes and explanations are described at the slide. Weather research and forecasting was chosen as a weather forecasting model. It's a next generation numerical weather forecasting system developed for both atmospheric and operational forecasts. VRF can perform simulation based on actual atmospheric conditions or idealized conditions. VRF offers an operational forecasting flexible and efficient platform reflecting the latest advances in physics, numerical solutions, and data assimilation that is shown at the shim. Interpolation tools provide the ability to create a continuous, predictable surface by value from anchor points. Input points can be located either as a regular grid or randomly. Inverse distance weighting algorithm is one of the deterministic interpolation. Calculates the results based on the measured values that fall into the vicinity of the interpolated point and on given mathematical formulas that determine the smoothness of the result surface. For simplified calculation, GDAL library was used. All operations with vector and raster are carried out the virtual memory of the library, which made it possible to avoid writing file to the hard disk. As a result, georeference image was obtained. After that region with no data were cropped, changed color scheme and cutting the image into tile for faster rendering. The third part is divided into 3 components. The first component is backend on Django. PostGIS was used as an extender for PostgreSQL for simplifying work with types like geometry, geography, and raster. The second one includes the Docker settings for deployment. The deployment application include Docker files and scripts files that are responsible for running each container. And the third one is a front end. Since this web application is a single-page application, it manages the transfer of data and node views. The system implements data caching, which make it possible to speed up data exchange between the client and the server. There is schemes shows single directional data streams in system and state management, which allows reactively track changes. To adjust the model, the data of its forecast for the past were compared with the real reading of the state weather station of Ukraine. Using the Python programming language, interpolation was carried out between these points. This model were compared with data from the real sensor in such parameters as temperature, wind speed, humidity, pressure. It was decided to compare the results of the predictive model with the forecast autoregressive model used to describe stationary stochastic process. Difference between the VRF and ARIMA lower than 1 degree, so root mean square error were calculated to assess quality of their prediction. VRF GFS model has approximately 1.29, when ARIMA model has 1.33, so its mean VRF is more accurate than ARIMA model. However, VRF can be improved by using post-processing like multi-sensor advection diffusion, of using satellite observation to detect the clouds and diffuse the clouds. As a way to transfer station data, the architectural approach REST was used. By selecting station, user open information tooltip is current value and model window is historical data. Air quality interpolation was saved as a raster tile in Amazon Simple Storage Service and displayed as a raster layer on the map using Mapbox.gl library. Using architectural approaches and technologies which were described, a system was developed which aggregate data from ground station, make prediction and build interactive views of aggregated data. In future, we are going to improve prediction of VRF using neural network as post-processing tools to prevent mathematical deviation of model. After forecast improvement, will be attempt to make system more flexible and stable by separate parts of project in its own server instances. The described architecture is used in the Your Air Test air monitoring information system. Thank you for attention.